In this video, we are going to be learning about energy. So by the end of the video, you should be able to define energy, explain the 5 main types of energy, compare and contrast kinetic and potential energy, use the equation Ke equals m times v squared divided by 2 to calculate kinetic energy, use the equation GPE equals weight times height to calculate potential energy, and be able to explain the law of conservation of energy. So looking at this, there is a lot that you should be able to do by the end of the lesson. Don't worry, we're going to go through everything and you will get chances to practice as well. So what is energy? Well, energy is the ability to do work. And we know from previous lessons that to calculate work, you need to take force times distance. And energy is like work as it's measured in joules. So when you're doing energy equations, no matter it's kinetic energy or potential energy, it will always be labeled in joules. So there are 5 different main types of energy that we're going to talk about today. We've got mechanical, heat, chemical, electromagnetic, and nuclear. Some of these you may have heard of in previous classes or maybe even just around the house. Well, the first one is mechanical energy. This is the energy of motion. So you riding your bike, driving your car, taking the bus, a fan going, things like that. Those all have mechanical energy. But what about heat energy? Well, heat energy is internal motion of particles of matter. It often causes temperature changes and phase changes. So fire is heat energy. Anytime you're boiling water, you're applying heat energy. When you're going for a run outside, you're increasing the heat in your body, which is another form of heat energy. Friction can have heat energy as well. Anything you can think of that causes things to get warmer or produces heat is using a form of heat energy. Chemical energy. This is when atoms are bonding together. So through semester 1, we were talking about chemistry and chemical bonding and how different elements come together. Well, when they come together, they are giving off chemical energy. They are bonding together using chemical energy. Electromagnetic energy. This is anything that has an electrical charge moving through it. So your plug-ins, your light bulbs, your power cords for your TV, your power cords for your fan, your charger. Anything that requires electrical energy to be used is electromagnetic energy. And this is seen on the electromagnetic spectrum. And now nuclear energy. This is contained in the nucleus of the atom. So this is when when an atom is giving off neutrons or protons. So anytime we say that an atom is giving off one of those two things, it's gonna be nuclear energy. So now let's talk about kinetic versus potential energy. All 5 forms that we've talked about can be divided into one of the categories. And kinetic energy is the energy of motion. So anything that is moving has kinetic energy. Potential energy is stored energy. So anything that is sitting at rest, like maybe you right now, or the chair you're sitting in, the table that the computer you're using is on, your bed in your bedroom. These all have potential energy because they're not moving. But if you got up and you ran around and you did some jumping jacks or something, you've converted that potential energy that you had inside you to kinetic energy because you went from sitting still to moving. So, like I said on the previous slide, kinetic energy is the energy of motion. And in order to calculate kinetic energy, we use the equation KE equals mass times velocity squared divided by 2. And the units for kinetic energy are, like I said a few slides back, are joules, or they stand for kilograms times meters squared divided by seconds squared. But the easiest thing for you to write is joules. Alright, so now let's try to calculate some kinetic energy. So the first problem here is, what is the kinetic energy of a jogger with a mass of 81 kilograms traveling at a speed of 2.5 meters per second? Remember, our equation is KE equals mass times velocity squared divided by 2. So, our mass is 81 kilograms. Our velocity is 2.5, and then we'll have to square that. And then we divide all of that by 2. And when you plug this into your calculator, you should get a kinetic energy of 253.1 joules. Alright, so let's try the next one. What is the kinetic energy of a 0.5 kilogram soccer ball that is traveling at a speed of 3 meters per second? So again, plugging this into the equation of above, we're going to put 0.5 kilograms times 3 meters per second and square that, divided by 2. Plugging this into your calculator, you should get a kinetic energy of 2.25 joules. Alright, let's try some more. So, what is the kinetic energy of a 45 kilogram object moving at 13 meters per second? So, again, just like the last two equations, we have to put our numbers into the KE equals mass times velocity squared divided by 2. So, our mass is 45 kilograms, our velocity is 13, and we have to square that, then divide it all by 2. So if you plug this into your calculator, you should have a kinetic energy of 3,802.5 joules. Now the next one is a little bit tricky because we're not looking for kinetic energy. Instead, this time we're looking for velocity. So the kinetic energy of a boat is calculated at 52,000 joules. If the boat has a mass of 39,000 kilograms, with what velocity is it moving? So using the equation above, we need to find a way to get velocity by itself. So the easiest way to do this problem is to put all the numbers in and rearrange as we go. So our kinetic energy is 52,000. Our mass is 39,000. We don't know our velocity over 2. Okay, so the first step we're going to do is we are going to multiply both sides by 2. And if you take 2 times 52,000, you should get 104,000, which is equal to 39,000 v squared. Then divide both sides by 39,000. And you should end up with 2.67 equals v squared. Well, then, in order to get rid of the squared, we have to square root both sides. So now, you've got to take the square root of 2.67, and you should end up with a number of 1.63 meters per second. All right, so like I said, the easiest way to do these problems is to put the numbers in and rearrange as you go. If you want to rearrange the equation beforehand, you can do that. And if you do, your equation is going to look like this. All right, so now let's talk about potential energy. Like I said on a previous slide, potential energy is stored energy. It's the energy that is sitting in an object at rest. And some examples of this would be like a stretched rubber band. Not you stretching it back and forth, not you starting to stretch it. It's when you've pulled it all the way out and you are holding it completely stretched out. The other example is water that is being stored behind a dam. So that water is being forced to a rest behind this dam. If the dam were to break or they would remove the dam, it would move back into kinetic energy again. So, gravitational potential energy, this is how we are going to calculate potential energy. So the equation for this is GPE equals weight times height. So if you remember from the first or second unit in this semester, we learned how to calculate weight, which was mass times gravity. So if I ever give you a mass number and I tell you to calculate potential energy, you have to convert it to weight first. And looking at this equation, you can see that the potential energy is dependent upon the height from the surface or the ground. So when we are calculating potential energy, you will always be given a distance of some kind to help us figure out what the GPE is. Let's do some practice. So the first problem here says a book weighing 8 newtons is on a table that is 0.75 meters high. What is the GPE relative to the floor? So remember, the equation is GPE equals weight times height, and our weight is 8 newtons. Our height is 0.75 meters. If you plug that into the calculator, your GPE should be 6. And remember that I said any energy that we are calculating is labeled in joules. So you would have a GPE of 6 joules. All right, let's try the next one. So the world record for pole vaulting is 6.15 meters. If the pole vaulter's gravitational potential is 4,942 joules, what's his mass? So now we are given the GPE and we want to know what the mass is. So we could rearrange the equation to be GPE So if we rearrange this equation, we are going to have weight equals GPE divided by height. So let's start with that. 4,942 divided by 6.15. You should get a weight of 803.6 newtons. But remember the problem is asking for is mass. Like I reminded you on the previous slide, our weight equation is mass times gravity. And gravity is 9.8 meters per second squared. So if we take 803.6 divided by 9.8, that should give us our mass. And the mass of the pole vaulter would be 82 kilograms. All right, you will get some more practice to calculate potential energy and kinetic energy in worksheets and in your lab. Now let's talk about the fact that energy can be converted from one form to another. So in the example below, we have a light bulb, which is converting electric energy to light energy. So it doesn't have to be one type of energy. It can use one to create another. Like with the light bulb, you put it into the socket and it's using electromagnetic energy to create light energy. So let's look at these pictures and see if we can figure out what type of energy is being used and what is it being converted to. So the first one we have is the car. Well, what do you put in a car? You put gas in a car. And when gas burns, it's a chemical change. So you are going to have chemical energy to start, and it's going to convert to mechanical energy because it moves. And mechanical energy is the energy of motion. All right, what about the windmill? This is moving. It's taking the energy of the wind, so it's moving, taking mechanical energy and converting it to, well, we use windmills to help provide electricity, so it takes mechanical energy and converts it to electromagnetic energy. All right, let's try two more. So what about the candle? So candles, you may want to say that this is being converted to heat energy, and it is. So you wouldn't be wrong in that case. But you don't typically use candles to heat up your house. So this, we would say, is converting to light energy. But what is it converting from? Just like the car, it's not burning gas, but it's burning something, and burning is a chemical change. So this means we are going from chemical energy to light energy. Now solar panels. Okay, so solar panels, again, another renewable energy. It's taking the sunlight, so it's taking light energy and converting it to, well, again, just like the windmill, we use solar panels as another form of electricity. So it's taking light energy and converting it to electromagnetic energy. All right, so these may be kind of tricky in some cases. So you will get some more practice before the test to do this. It will be on your worksheet as well. If you have any questions and you're not really sure where to go with this, please contact me and I will help you out. All right, so the last thing I want to talk about in this lesson is the law of conservation of energy. This states that energy can neither be created nor destroyed. The energy that we have in the world and in the universe is all the energy we're ever going to have. So in a system, if let's say you have 10 joules of kinetic energy and then 5 minutes later you're calculating that it only has 6 joules of kinetic energy, that energy is not being lost, rather, it's being converted. It could be converted to heat energy, to light energy, some other type of energy, but it's not just disappearing into thin air. And that's what this law is saying, that if for some reason something has more energy, that doesn't mean that it's being created, it's just being converted. So now let's just do a little bit of recap. We know that energy is the ability to do work. And we know there are 5 main types of energy. We've got mechanical, which is the energy, which is motion. We've got heat, which is temperature. We've got chemical, which deals with bonding or burning. We have electromagnetic, which deals with electricity, and nuclear, which deals with nucleus of an atom. We know that kinetic energy is the energy of motion, and potential energy is stored energy. We know how to use the equation KE equals mass times velocity squared divided by 2 to calculate kinetic energy. We know that the equation to calculate potential energy is GPE equals weight times height. And we know that the law of conservation of energy states that energy can neither be created or destroyed. So, if you're looking at some of this stuff and you're like, oh, well, I'm not really sure that I know that, go back and look at some other parts of the lesson. Otherwise, send me an email, send me a text message, and I will explain it a little better for you. Otherwise, this is the end of the lesson, so have a great day.